Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thanks for joining us on the podcast known as Space Nuts, 2 to a pack. My name's Andrew Dunkley, and joining me, as always, from the Australian Astronomical Observatory is Fred Watson. Hello, Fred.
Hi, Andrew. Hey, you'd be pretty miffed if you bought a pack of nuts and there were only 2 in it. Unless they were coconuts or something like that. That might be all right.
I think I bought a packet of Twisties once and it had 4 in it. For those who don't know, Twisties are a sort of a savoury snack in Australia that I absolutely adore, a cheese snack. But I got mega ripped off that day. But it happens. It does happen. I think it must have been a bad batch. Or it went through
just like us.
Or it went through the self-sealer too fast or something like that. I don't know. Still cost me the same price. Now, today, Fred, we're going to look at a disco ball in space. This sounds like something a Kiwi would think of. We're also going to look at what Elon Musk is up to, and as soon as next week, we think he might be up to something, and, we'll assume it's going to happen until it doesn't. And an audience question, interesting one. We've spoken many times about gravitational waves. Well, now we've got a question from somebody who has a question about a potential effect of gravitational waves. So we'll get into that. But, this, I can't help laughing. The disco ball in space. And it does look like it's a New Zealand project.
I'm a great admirer of what's been happening in New Zealand, Andrew, with the this new.
Oh, look,
American...
no, don't get me wrong. I'm not having a go, and they do awesome things with sheep. But what about space?
I'm not going to touch that one. This American startup company, Rocket Lab, who are, of course, very heavily involved with New Zealand and New Zealand Space Agency, they are launching rockets from New Zealand. They are expecting to put spacecraft into orbit once a week. That is just brilliant.
It is.
Grabbing a niche in the small payload market that is probably not that well served by the major companies. They go for the 10-ton payloads going up to geostationary orbit, which means big rockets, whereas the Rocket Lab electron boosters are a relatively modest size, but they do the job. They get things into orbit. So last week, there was a Rocket Lab launch, which is from their launch site on the North Island. It's the Mahia Peninsula in the North Island. I hope I'm saying that correctly. And it interested the what you might call the amateur space watching fraternity, because all over the world there are enthusiasts, and at a very low level I'm one too, who watch the details of space launches and look at what has gone into orbit, and they can usually do fairly elementary calculations. Well, this thing put 5 pieces into orbit, and all of those are accounted for by either spent rocket boosters or the satellites that have been launched. So that's that's a fairly standard way of doing it. But on Sunday last week, these satellite watchers found a 6th item in something they were expecting to be only 5. And very soon there was an announcement about what this 6th item was. And it is a giant disco ball, exactly as you've said. So it's a geodesic ball. It's got highly reflective segments. It's well over a metre in size, probably maybe just over a metre, I would say. And that's quite a sizable thing to launch into orbit, so it's quite impressive. I think it's made of kind carbon fiber or something pretty light, it's basically into a standard orbit, which means it orbits the Earth every 90 minutes. But because it's got these reflective sides, it does its job, its one job, which is to reflect light from the sun down to the Earth. And
just like being in a disco where they put a spotlight on the ball and it reflects light in
that's
little
correct.
beams all over the place.
Except, of course, it's you don't see these spots of light rushing across the Earth as you do in a disco. If I remember what discos are like, but it's basically all about putting an object in space that people can see. And in fact, the CEO of the company, his name is Peter Beck. He's christened this thing the Humanity Star, so that everybody can see it and basically think beyond our confines of Earth and perhaps think about humanity as a species, all of which I applaud wholeheartedly.
So it has no other purpose than to be something to look at.
That is correct. So I applaud the idea of bringing the populations of the Earth together, but I'm not that keen on launching bright things into space. And that's because my profession is
dark
astronomy.
Skies.
And night skies. And in fact, as you know, I chair the observatory's Dark Sky Committee, which is all about keeping the sky naturally dark. And so, the disco ball clearly doesn't threaten the night sky in a big way, but it does have an influence on anybody who is, for example, doing imaging of distant objects in the night sky, and that includes both professional and amateur astronomers. And there are very, very many amateur astronomers who take these digital images now of deep space objects. And the last thing you want in one of these images is a bright streak across it as a satellite goes over. And if that bright streak is meant to be reflective and actually intended to be, then it's going to be brighter than ever. And it will irritate a lot of people.
I'm sure it will. And you're talking about long exposure type photography and also, in the digital age, there's all sorts of things that people are capable of. But a bright object spinning across the skyline that you're trying to photograph could be, a pain in the posterior.
Yes, exactly.
Typical Kiwis.
Well, no, I don't blame the Kiwis.
No, I'm not.
There is I suppose what you might call a school of thought that says we should use space for exactly this kind of thing. And in fact, back in the 70s and 80s, there was talk of giant billboards orbiting in space, which would be used by advertisers. Well-known soft drink manufacturers are one company that comes to mind. These were knocked on the head because of their damage to the nocturnal environment. But there is still ideas of putting up satellites which have what you might call an aesthetic purpose, which is certainly what the Humanity Star is all about, which would illuminate the night sky. Sculptures have been, have been targeted to go into space. It all sits rather unhappily with the dark sky movement, just because it adds something unnecessary to a problem that is really still growing. Of course, cities are the big culprits. They light up the night sky environment of anybody living there, and have by and large taken the sky away.
Of course, the great city of Dubbo, the western megalopolis of New South Wales, is not one of those, because we have low intensity lighting that is capped.
And the reason for that is because you are within 100 kilometres of Siding Spring Observatory, which is where I'm sitting right now.
Yes, indeed. I've had a couple of little cracks at the Kiwis, but that's because I'm Australian and it's just, in our nature. But they weren't the first. The Russians put a mirror up not so long ago, didn't they?
Yes, that's right. Yeah, they did.
And that was for exactly the same purpose on a much grander scale, I think.
I think that's right. That's correct. I don't want to make it sound as though astronomers are killjoys, because that's not our intention. We want to celebrate all the same things that Rocket Lab wants to celebrate with their Humanity Star project. The one good thing about it is that it's in a low Earth orbit, which will decay fairly quickly, and so I think it's only going to be up there for 6 to 9 months or so before it burns up in the atmosphere.
So where do we see it? Is it easy to spot?
Yeah. So at the moment, they are putting together a website, because you can't just kind of look in the sky and say it's all in a certain place. It's very location specific.
So it's not emitting Bee Gees music or anything, so that won't, we can't narrow it down.
Not yet, no. It's not. The Rocket Lab is basically about to host a website that will be a bit like the Heavens Above website. You put in your location, and it'll give you, an update on the passage of this object through space.
Very good. All right. Well, it'll be something to look out for, and do a bit of a search on your favourite website search engine and see if you can track down the Humanity Star or the New Zealand Disco Ball. Trust them to pick an era that's long past. But then again, they called their company Rocket Lab, so what do you expect? But sounds like fun, and I'll keep an eye out for it. You're listening to Space Nuts. Andrew Dunkley with Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by Tech Radar. This is the one I use. I've been using it for a couple of years, and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons, and there was just something about their business model that I particularly liked, and a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
0G, and I feel fine.
Space Nuts.
Now, Fred, we're going to talk about Elon Musk. This bloke amazes me, and not unlike what the Kiwis have done, launching something of a humanitarian nature into space, Elon Musk seems to have that kind of philanthropic approach to the world, and is trying to make the world a better place through renewable energies and super batteries and all that sort of stuff, although the people of Adelaide are still trying to figure out what this button does. But right now he's gearing up for a big launch that's going to happen next week, and he's using his Falcon Heavy rocket, and he's sending up something even a bit more bizarre than a disco ball. What's he up to?
Yeah, so you're quite right. All the action for this is next week. So if you're listening to this after February the 6th, you might get a different take on the story. But it's a very exciting venture. So his SpaceX company will test launch what is now the world's most powerful rocket, the Falcon Heavy, which has the extraordinary capability of being able to put 62 tons into low Earth orbit. That is... It's almost the size of a railway locomotive. Is that? It's extraordinary capability. But of course, Elon Musk's sights are firmly fixed on the planet Mars, because he has plans to get rockets to Mars. I have to say that whilst I'm a very big fan of Elon's, I actually think some of this hype is very optimistic. There are huge technical problems in getting people to Mars, which we really aren't very near to solving at the moment. Notwithstanding that, though, the Falcon Heavy, when it comes into being and comes into operational service, as you could perhaps say, will be an amazing addition to the world's store of rocket launch vehicles because of its capabilities. So it consists of 3 of his Falcon rockets strapped together in a row, not end to end, but side by side. Each one of those has 9 rocket engines, so it's a 27 rocket spacecraft, 27 rocket motor spacecraft. That in itself brings interesting problems because when you fire all these things together, there are all kinds of vibrational patterns that get set up, and if you're not careful, it tears your spacecraft to pieces, as the Russians found out with their N1 program back in the 1960s.
Is that different from harmonic vibration that tears planes apart?
It's that sort of thing, that's right. The N1 rocket had 30 engines, so SpaceX is not far.
They were asking for trouble. They really were.
That's right. It's not far short of that. So, but all the signs are good. I mean, the Falcon rockets with their nine motor cluster are already doing brilliantly in terms of putting things into orbit. They're providing commercial services to NASA. And of course, the key thing about them, and this is really where I think everybody has to take their hat off to Elon Musk, they've mastered the technique of bringing the rockets back down to Earth, landing them either on a pad at Cape Canaveral or on the floating drone barge that Elon Musk has got sitting in the Atlantic Ocean. It's got a lovely name, has this barge. If I remember rightly, it's called Of Course We Still Love You, which is a great way of welcoming back your spent...
I've seen footage of those rockets coming back down on that barge, and it still doesn't quite look real. It's like you're watching an image from a science fiction movie or some kind of CGI effect, but it's absolutely real. It just looks so spectacular.
Indeed, and it is. It's a spectacular achievement, especially when you think this this landing platform is pitching up and down by 10 meters or something as in the Atlantic swell. But they've done a great job with that, and the success rate has now improved. It started off pretty feebly, but it's now pretty good. So that's
a bit like the Australian cricket team, but we won't go there.
We won't go there either. No, that's right. Now, so the amazing thing is that on Tuesday, when this rocket test launch will take place, Elon is planning to bring all 3 of those rocket boosters back to Earth. Wow. One of them, I think, the central core will land on the Atlantic floating platform, and the other 2 will land on the ground. Yeah. That's very, very ambitious. And I think he's half expecting it to end in tears. But what he has done to put his money where his mouth is sent this extraordinary payload up with the rocket.
This is like he's made a personal bet against himself.
That's right. It's almost like that. That's right. So normally when you test a new rocket, the payload bay is filled with blocks of concrete or something like that, just useless ballast. But he's put his own Tesla Roadster into the payload bay, and not only is it going up into space, it's actually going to Mars, because he's putting it into an orbit which will intercept the orbit of Mars. And
seriously?
He expects it to be in that orbit for about 1 billion years, unless he gets there first and brings it down onto the surface.
You're kidding me.
Yeah, it's going to Mars. That's the deal.
I'm just looking at an image of the vehicle right now. Oh my gosh!
It's a lovely cherry red Tesla Roadster. I've been in one of these cars.
It's incredible.
Andrew, 'cause I have a friend who's got one, and they are stunningly spectacular. If I had one, I certainly wouldn't be sending it to Mars, but maybe if you own the company that makes them, you're in an unusually privileged position.
At least you picked the right colour.
Yes, he did. I think that's his favourite.
And we are now. Let's get serious. We are talking about a $200,000 vehicle.
Yes, that's right.
US.
Which is nothing really compared with the cost of the launch, but that's all right. Look, I think it's a really great story. I wish him well with the project, because I think this is very much putting space within reach of so many different groups of endeavours, not only scientific and commercial, but maybe tourism as well. Who knows?
Yeah, maybe. Look, I just figured it out. It's a 10-year-old car. I mean, come on, it's an old bomb. Just had to get rid of it. That's what it is.
Yeah. I don't know whether you can use the word Tesla and bomb in the same sentence.
Got a feeling you can't, but I just did. But I can't wait to see the launch. If he pulls it off, though, Fred, he's going to get publicity worth millions and millions of dollars.
Indeed.
The media will go crazy over this, as we have already done so today.
As we've already done, yeah.
All right, we watch with interest. A launch of a Tesla Roadster to the red planet is beyond my comprehension, but good luck to him. I hope he does it. I really do.
Yeah.
Now, this is Space Nuts. My name's Andrew Dunkley, and with me, of course, is Fred Watson.
Roger, your last clear here also.
Space Nuts.
Last but not least, Fred, a question from our vast audience, and we thank Chris Rostron for this question. We do encourage your questions. We love to hear from you, because you're certainly proving you're a lot brighter than I am in terms of what goes through your mind, because I would never have thought of this. But Chris writes, Fred, if the distance light travels can be explained by the amount of redshift, does the expansion of the universe affect gravitational waves in a similar way? And if it doesn't, could that indicate properties of dark matter? What's he asking?
It's a great question, Andrew, and it's right on the money, because the bottom line is yes.
And thank you for joining us today. We'll be back next time. I love that joke. I use it a lot.
Yeah. Well, all right. Well, you explain it then.
I have no idea. I've got no. Like I said, they're brighter minds than mine. But okay, so it's yes. Why is it yes?
Okay. So think first of all of light waves coming from something very, very distant, something which we only see as it was, say, 1 billion years ago. Right. So the light has been traveling through the universe for 1 billion years. And during that time, the universe has expanded, because that's what space is doing.
Yep.
And so as part of that process of expansion, what happens is the light waves get stretched, and they end up with a longer wavelength.
Mm-hmm.
Now, scientists equate the wavelength of light with color. So blue light has a short wavelength, and red light has a longer wavelength. So as the universe expands and light travels through it, the light is shifted towards the red end of the spectrum, and we call that the redshift. So gravitational waves are not like light. They are quite different waves, and they are moving through the fabric of space itself as a sort of vibration of space. But because space is expanding, they too undergo what might be called a redshift. Their properties change. There's a big difference, though, in how you can interpret this, because the way we measure the redshift of an object is we look at light whose wavelength we know when it's set off. And so
so you know what the starting point is.
You know what the starting point is, and because that depends on what element in the periodic table is actually emitting the light. For example, hydrogen has got a very well established what we call a rest wavelength. It's hydrogen atoms always emit light of this wavelength, and so if you can detect hydrogen at great distances in space, you'll find that it's no longer emitting light at that original wavelength. It's been stretched into something else. So that actually allows us to work out the distance of these distant objects, because we know how much stretching has taken place. But with a gravitational wave, you don't, because the initial wavelength depends on the masses of the objects that are causing the gravitational wave. and the exact circumstances of that gravitational disturbance to set up the ripples in space. So you basically don't know what the initial conditions are, which makes this a much less useful redshift than the redshift of light or radio waves. Okay. But the second part of the question, though, is sort of on the right lines too. Whether dark matter can affect this. Dark matter is something whose existence we know about. It's like normal matter, except it doesn't interact with normal matter, but it does have gravity, and that's why we know it's there, because we can see its gravitational effect. We know it makes up 5/6 of all the matter in the universe. Now, I think from what I've read about redshifted gravitational waves, a more likely influencer of gravitational waves is the other dark component of the universe. The much bigger one makes up 75% of the universe, and that is dark energy. And this is this property of space itself that is pushing it apart, so that dark energy is what's causing the expansion of the universe to accelerate. And I understand from my reading of the theoretical physics here, and I have to say that that's fairly cursory, that there are certainly likely to be influences between dark energy and the redshifting of gravitational waves. I might try and find out a bit more about that, because it's quite an interesting topic. But the question is right on the money, and congratulations to our very, very erudite listeners of Space Nuts.
Yeah, and so the first half of his question, the answer was yes. The second half of the question was, we don't know.
Maybe, don't know. Yeah.
I hope that satisfies you, Chris. But keep the questions coming, because we do enjoy trying to sort them out. Sometimes they hit us a curveball, don't they?
Well, that was pretty curvy as well. It's a great question, and it's one that we scientists ask each other. Oh, do you get redshift in there? Yeah, that sort of thing.
Okay. You can certainly send us questions via Facebook and via Twitter, and or any other way you can find us, via some of our podcast platforms as well. There are many. Fred, as always, thank you so much. Real pleasure, lots of fun, and I think we've done enough to the Kiwis this week, so I'll give them a bit of a break. But hey, if their disco ball gets smashed by a Tesla vehicle, so be it. And we'll see you next week.
Sounds great. Thanks, Andrew.
That's Fred Watson from the Australian Astronomical Observatory. Thank you for listening to Space Nuts, and we look forward to catching up with you again very, very soon. Bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor.
This has been another quality podcast production from Bytes.com.